Good afternoon, class. I'm Mr. Precella, and today we're going to be looking at the first topic in our course. It's a review of square roots. So if you haven't seen square roots, then in a while this should help you remember what a square root is. And let's get switched over to my paper. This symbol here is called a radical or a square root symbol, and we say the square root of 25, that equals the number 5 because 5 squared, 5 times 5 is 25. That symbol, as I said, it's the square root symbol, or more general, we would just say it's a radical. I call that little symbol there a radical, R-A-D-I-C-A-L. And the number underneath the square root symbol, that 25, we refer to as the radicand.
Or else we call it the number under the square root symbol.
Yeah. But
I think
the square root of the number underneath there is equal to the number that can be squared to give you back that radicand. And for example, number 1 in our assignment.
What's going on? Where's the assignment? Oh, right there. Problem for that.
Okay. Problem number 1. Let me write this problem down, and then Tony will switch back to the paper. Okay.
Square root of 100.
Square root of 100. What number? Here's what you're asking yourself. What number can I square to give myself 100? What do y'all think? Now, I should mention something. That symbol, I said it's called a radical or square root symbol. Formally, it's the principal square root, which means the positive number. You're thinking to yourself, well, negative 10 times negative 10 is a positive 100. But that symbol, there's no sign, there's no negative sign in front of it. So we're looking for the positive square root of 100, which is equal to 10. So we go back to our homework, and we go to the blue box, and we type in the number 10.
And check our answer.
Okay. And go on to the next question. Okay, number 2, it's another square root problem. Here it's the square root of 169. So you're asking yourself, oh, by the way, here we said that was 10 because 10 squared is 100. You're asking yourself, what number can we square to give ourselves 169? 13? Check that on your calculator. What's 13 times 13? Is that 169?
Let's see. I'm going to do this. The square root key is in yellow, so second square root, 169, close the parentheses, enter, 13. 13 times 13 is 169.
If you can find the square root of the number, and it's just an integer, not a messy decimal number, we call that a perfect square. So 100 is a perfect square, 169 is a perfect square, the number 25 is a perfect square. Suppose we have a number that's not a perfect square. Go ahead and type in that answer.
Before I do, I want to demonstrate something. The answer is what? What's the answer to this? 13. I just want to demonstrate what would happen if you get a problem wrong. You check it. Oh, it's saying no, you got it wrong. Let me change it from 11. I'm going to put another wrong answer. 12. 12 times 12 is 144, so I know it's wrong. No. It says try again.
And notice it now says final check. This is your last chance to put in the correct answer. And the correct answer is 13. No,
No.
you're about to
I
mess it up.
know. Because I wanted to demonstrate. Okay, so the correct answer is 13. You now have an option. You can move on, get that problem wrong, or what you should do is click similar question. And now I'll get it right. What's the correct answer for this one? I'm going to get it right this time. What times what is 121? And I can already tell it's going to be a big number day. Yeah, on these. What's the square root of 121? Is it an integer or is it a decimal?
10 squared is 100, so it has to be bigger than 10. What's 11 times 11? 121. So the square root of 121 is 11.
You'll know it. Notice at this point the red X that I'm pointing at. That means I got problem 2 wrong. I'm about to input 11. Check it. I got it right. And look, I now have a check mark. Okay? So I got that one right. That's why we said you can make 100 on every assignment. Okay? Just rework it till you get it right. Oh, 150? What happens if I punch in the square root of 150 on here? It's a decimal number.
150 is not a perfect square. We should let's list out some perfect squares.
These are the numbers whose square roots are not decimals. They're just integers, which are the counting numbers and their negatives.
Well, I'll get us started. 1 squared. 1 times 1 is 1. 2 times 2 is 4. What about 3 squared? What's that? 9. 4 squared? 16. What's the next one?
5 times 5.
25. 6 squared? 36. 7 squared? 8 squared? 64. 9 squared? And how long can we keep doing this? 10 squared we know is 100. 11 squared? 121. 12 squared? 144.
And that's where traditionally the multiplication table ends.
13 squared, 13 times 13 we saw was 169. 14 times 14.
Let's say dot, dot, dot.
Let's go until 50.
Oh, okay.
14 times 14 is 196. 15 times 15 is 225, and hopefully that's big enough. Hopefully we won't need any perfect squares bigger than that. But if you're trying to reduce the square root of a number that is not a perfect square, you're going to have to ask yourself, what's the biggest perfect square that divides evenly into that number? So number 3 was what? The square root of 150? What did they ask for? The square root of 150? Okay.
I think I heard someone answer your question.
Mm-hmm.
What's the biggest?
Okay, you got it. Okay. So, well, how did you choose 25? You ask yourself, what's the biggest number up here that divides evenly into 150? By dividing evenly, I mean it goes in without a remainder. Okay, so, and 25 is the biggest number up here that divides evenly into 150. What's 150 divided by 25? 7?
6.
6. I think it's 6. You're right. Okay. So it's you think of 150 as 25 times 6, and then we write that separately. It's the square root of 25 times the square root of 6. I'm going to be skipping this step right here. From now on, if I'm trying to reduce a square root that's not a perfect square, I'll go straight to this step here. And now what's the square root of 25? We've already said that. 5. Will any number up here in this list divide evenly into 6 other than 1? The number that's left under the radical can only be divisible by the number 1. If a perfect square divides unevenly into it, then you don't have it reduced. You have to use the biggest perfect square that divides evenly into the radicand. The square root of 6. The only number up here that divides evenly into 6 is 1. So that 6 is perfectly fine. You write your final answer as 5 square roots of 6.
When you do the next one, maybe use 2 different colors.
Any questions there?
How do we
If
type?
it's not a perfect square, you ask yourself, what's the biggest perfect square that divides evenly into it? You reduce the perfect square. You leave the other number underneath the radical. And how do you know that 150 isn't a perfect square? Because if you punch it into a calculator, the square root of 150 gives you a messy decimal number. And that messy decimal number never ends. When I say it's messy, it is an irrational number that cannot be, all the digits cannot be written out.
Mhm. Okay, so let's punch in. Look at how we're going to type in our answer. Sometimes students, how do I type in a square root? Click in the little box, and you have your tools right here. We're going to type 5, then hit the square. This is the square
Hover
root
over
key.
it. You see, use your bionic eye. Can y'all read that? It says square root. There's another radical right beside it. That's for cube roots and fourth roots. And we won't be seeing those today, but we'll see them in future assignments. The symbol you want is the square root symbol. You click that, and then underneath the radical, you type the 6. Check answer. Any questions there? Let's do another one. Hopefully it's one that's not a perfect square. And I think it is. I think it's not a perfect square. It's the square root of 18. And let me push my paper up. The square root of 18. You ask yourself, well, first of all, if you look on your calculator and punch in the square root of 18, you're going to get a decimal number. But also, 18 isn't written up here as a perfect square. So 18 is not a perfect square. What's the biggest number in this list of perfect squares that divides evenly into 18? 9. So you're going to think of it as the square root of 9. 9 times what? 9 times what gives you 18?
2.
Okay, so the square root of 9 times the square root of 2. The square root of 9, how are we going to write that? 3.
Go blue.
Oh, 3 square root of 2.
The blue square root of 9 became a blue 3. The black square root of 2 stayed a black square root of 2. Just to make sure you're seeing where we're getting these numbers. The square root of 9 becomes 3. The square root of 2 stays square root of 2. So, notice I get so many emails. It didn't show me the square root button. You've got to click in it first.
Click in the blue box before the toolbar appears. Also, if you're trying to type a special symbol that doesn't appear in the toolbox, that means you're trying to type something that's wrong. If you need a square root in your answer, when you click that blue box, it's going to show the square root symbol. If you need a fraction and you click in that box, it's going to show the fraction symbol. Any questions? Number 5.
Square root of 29. It's worded differently from the other ones, notice.
The instructions say simplify the square root. There's no variables in this one. If the square root is already simplified, so state. Oh, they're sounding fancy in
I
those
wonder why they don't say
instructions.
states. I guess ChatGPT told them to write so state.
Okay, is 29 a perfect square? Here's my list of perfect squares. Y'all see it listed?
Well, any
No.
of these numbers divide evenly except for one.
It would have to be a number smaller than 29. Does 25 go evenly into 29? No, if you tried to divide it, it'd be 1 remainder 4. 16, 9, 4, to any of those numbers other than 1, divide evenly into 29.
Look, I've shown my thoughts right here. 29, it's just giving me decimal numbers. None of those numbers divide.
Therefore, the square root of 29 cannot be reduced any further. 29 is a prime number. You're not going to rewrite the square root of 29 as anything other than just the square root of 29. Oh, I'm supposed to say
is already simplified.
Already simplified. You're right. You have to go to the problem and select the already simplified. I wonder if you wrote the square root of 29, would they take it? What do y'all think? If you just wrote the square root of 29 again, the square root of 29 is equal to the square root of 29.
I think what they want you to do is already simplified.
But let's see if they take this.
No.
All right.
Oh,
so
wait.
Select already simplified. There it is.
Mm-hmm. If at any time, if you need to get out of this, quit, go do something, you can click save. It'll save it. In fact, you see how the grade's changing right here? The Pearson grade book updates automatically.
If you get the problem right, the grade goes up. As you go through the problems, each time you get a correct answer, a green check, your grade on the assignment goes up. There's no submitting. Maybe you've worked with other courses where you have to submit stuff. Well, the only time you submit is on the test, okay? On the test, you have to put in all the answers.
Instead of a save button, it'll say submit.
But
yeah. Okay, here's number 6. Square root of 72. What do y'all think?
Number 6. Is 72 a perfect square? Look at your list of perfect squares. No, it's not a perfect square. Let's look and see. What's the biggest number that divides evenly into 72? It has to be under 72, so it has to be one of these numbers here. What's the big? 9 goes in evenly, but it's not the biggest. 36. If you use 9 times what gives you 72? 9 times 8? 8 is also divisible by 4. The number under the radical cannot be divisible by any other perfect square other than 1. So is that clear? You cannot use, okay, you can't say, well, it's the square root of 9 times the square root of 8. The square root of 9 is 3, but 8 is still divisible by a perfect square. 4 goes evenly into 8. So that you cannot use 9. You have to use the biggest perfect square, and the biggest perfect square is 36. 36 times what gives you 72?
By 2.
36, okay, so it's the square root of 36 times the square root of 2. 2, it's not divisible by anything other than just 1. The number under the radical cannot be divisible by any perfect square other than 1. And what's the square root of 36? So you have 6 square roots of 2 for your simplified form. So we go back.
Notice it doesn't have the little buttons. You got to click and click. Now I type 6 square root of 2.
Oh, by the way, Pearson used to recommend Chrome or Safari as a web browser, but I've been using Edge at home and I haven't run into a problem with it, okay? So, and if you're using a Windows computer, Microsoft is stressing that they think that Edge is safer than Chrome. So,
Well, of course they're going to
if
say
you're
that.
using Edge, let me know if you experience problems with MyLab, okay? Anyone an Edge person? I used to use Windows Internet Explorer, but once they changed that name to Edge, I quit using it. I don't know.
Well,
Well,
let's go hard to number
because it
7.
mess up with
Let's go on to number
MyLab.
7.
Let's do it.
4307.
Okay, number 7. We have the square root of 98. Let's look at our list of perfect squares. Here it is. Is 98 a perfect square?
Nope.
No, it skips right over. It'd be between 100 and 81. So 98 isn't a perfect square. What's the biggest perfect square that divides evenly into 98?
49. I heard someone say it. Yep.
I agree.
49.
49 times what? 2. So you're thinking it's the square root of 49 times the square root of 2. The square root of 49. Tony wants me to use pink and red. If
No.
you have a problem focusing, some people have trouble focusing on colored ink like red and pink. So if you have trouble, just tell me and I'll
We
stop
don't have to
using
use
it.
that now.
The square
Stick
root of
with blue and
49.
green. Don't change the colors.
The square root of 49 is 7. The 2 stays under the radical for the final answer of 7 square roots of 2. Any questions there?
7 square root 2 enter.
Number 8.
Oh my goodness. It's a big one.
The square root of 1500.
We don't list the perfect squares that far. I'm just going to make sure 1500 isn't a perfect square, which it's not. So
1500 is not a perfect square. If you try to enter it into your calculator, you see you get that messy decimal number. What's the biggest perfect square that divides evenly into 1500? There's one number in this list that obviously divides evenly into 1500. 100. 100 divides in evenly. So we're thinking the square root of 100 times the square root of 15. The square root of 100 times the square root of 15. What's the square root of 100? 10. Now 15. Is there any number, you need to make sure, I should have done that earlier. Is there any number here in this perfect square list other than 1 that divides evenly into 15? 15 is 5 times 3. They're not perfect squares, so the 15 stays under the square root. Any questions there?
So 10 square root of 15. 10 root 15. Check it. Oh wow. This assignment has more problems than most. It has 20.
Usually we try to stick around 15 problems, but this one here has more, but some of the problems are pretty short, okay?
Number 1 and 2.
Yeah, that's what I was thinking of. Number 9. It's another simplify, the square root of 54. Oh, well, at least the number's smaller. Is 54 a perfect square? Let's see, 54 is between 49 and 64, so it's not a perfect square. What's the biggest number here that divides evenly into 54? 9 times what? 9 times 6? No perfect square divides evenly into 6. So I agree, we're going to use the square root of 9 times the square root of 6. What's the square root of 9? 3. What do I do with that pink square root of 6? Just write it down. Just carry it over. For 3 square roots of 6.
3 square root 6. Huh? 20 short years. Oh, another one.
Number 10. The square root of 350.
One thing about this course is all math builds. What we're doing today, we'll be doing at the end of the semester too.
You have to know how to reduce square roots in this course.
Because, oh, yeah, we just keep going and going.
Well, 350. Y'all think that's a perfect square? Do you think we're lucky? Is it going to be a perfect square? What do y'all think? Where's our calculator?
Oh, yeah, let me see. Square root 350. On this calculator, I don't have to close those parentheses. Nope. So
18 point something, so
look,
it's not a perfect square.
I'm going to start dividing. Here's my thought process. Well, how big should I try? It's got to be a number. If I've been all the way through, 350 divided by 225, of course not. 350 divided by 196, decimal. 350 divided by 144, decimal. 350 divided by 121, decimal. Oh, wow, this could be annoying. 350 divided by 100, decimal. 350 divided by 81, decimal. 350 divided by 64. 350 divided by 49.
He's just going through the list of perfect squares, trying to find
by
one that divides
36.
evenly into 350.
350 divided by 25. Okay.
There it is.
There's the
Okay. 25 divides evenly into 350, and it's 25 times 14. 14. Do any of these other numbers other than 1 divide evenly into 14? No? So they're using the square root of 25 times the square root of 14. What's the square root of 25? 5.
The black 5.
What am I going to do with the square root of 14? Just move it over to give us a final answer of 5 square roots of 14.
5 square root of 14. 5 square root of 14. Oh gosh, another one of these.
Okay, the square root of 90. Is 90 a perfect square? The square root of 90. Is it in our list of perfect squares? No? What's the biggest perfect square that divides evenly into 90? It's sort of obvious. 9. 9 goes in evenly. 9 times what? 9 times I can't hear you?
I heard 10.
Okay, so the square root of 9 is 3. The square root of 10, I just bring over to my final answer.
3 square root of 10. Now it's going to have to get more than just that. on this assignment.
Any questions?
I have a question.
Yes.
Okay.
What if the 10 was able to have a perfect square?
Then we wouldn't have used 9. The number underneath there that's left under the radical cannot be divisible by any other perfect square except for 1.
Why don't, for illustration purposes, to answer that question better, work number 6 with 9 times 8.
Okay, looking back at the square root of 72, we'd already said the square root of 72, we'd use 36 and 2, but suppose we had used 9 times 8. The square root of 9 is 3. The square root of 8. Look at this list. Does one of these numbers divide evenly into 8? Other than 1. I'm just going to mark off 1 because you never want to use 1. Does one of those perfect squares divide evenly into 8?
4.
I think 4. 4 times 2 gives you 8. That's why my lab would count that answer wrong.
But show how you can go ahead and keep on reducing.
Okay. 8 is divisible. 4 goes evenly into 8. So we have 3. You can think of 8 as the square root of 4 times the square root of 2. The square root of 4 is 2 times 3. What's that giving us? 2 times 3 is giving us the 6. What number do we have left under the radical now? The 2.
So you'll still get the correct answer, but you might have to simplify
on
it
going.
twice. That's why we start at the end of the list.
Trying to find the biggest
biggest
number that divides evenly into the radicand. You start with the biggest, you start at the end of the list, use the biggest number, and then you don't have to worry about, okay, do it again. Now find one that divides evenly into 8. Any other questions there? We're going to multiply square roots now.
So we're starting something new. Well, not really. We're still working with square roots, but here we're multiplying 2 square roots. If
To
you had
multiply 2 square roots,
I was going to ask them, if you were going to guess, what do you think we'll do to the 5 and the 15?
Separate the 15 and 5 and 3.
Oh, well, you're getting ahead of me. I was just going to multiply them together. But, oh, wow, I like how you're thinking. You're thinking much more advanced than I would do. Okay.
Yeah. Okay. I see what he's saying.
Yeah.
Yeah. That's not what I'm going to do here. I'm going to multiply the 5 and the 15 first and then reduce. But I like the way you're thinking because the square root of 5 times the square root of 5, we'll see it's going to become the square root of 25, which is 5. But okay, to multiply square roots, I'm going to say multiply the radicands.
Let me show this.
Multiply the radicands.
And then simplify.
And then simplify.
Like you did in problems 1 through 11.
And this is number, what problem?
12.
12.
Square root of 5 times the square root of 15. There it is.
If you're multiplying a square root times a square root, multiply the radicals. Well, we're going to keep the same radical symbol, square root. You multiply the radicands. 5 times 15
And probably the next
5
time you
times
won't write
15
that.
is 75. So we multiplied the radicands. That gave me a 75 under the radical. Is 75 a perfect square? No. What's the biggest perfect square that divides evenly into 75?
25.
25 times what will give you 75? 3. So here's how you're thinking of it. You're thinking of it as the square root of 25 times the square root of 3. And we know the square root of 25 is 5. And what do we do with that 3?
Let's leave it.
Keep it under the radical for 5 square roots of 3. When I'm multiplying radicals, I'll just multiply the radicands and then reduce.
But I like that idea, 5 times 3. Okay, so 5 square root 3. Check it.
Okay, number 13. Number 13 is trying to make an important or illustrate an important concept here. We have the square root of 11 times the square root of 11. The square root of 11 times the square root of 11. By my method, here's my square root. What's 11 times 11? 121. And what's the square root of 121? I recall 121 from my list of perfect squares. There it is, 11.
So I'm
The
wondering,
square root of a number times itself. If you're multiplying the square root of a number times itself, you're going to get just the radicand. You've dropped the square root. It's asking you, what do you square to give you that 121? It's just that number under the radical. And we need to make a note of this because this is important.
this is a rule they'll be using the rest of the semester.
The square root of A
For any number.
times the square root of A
Hey, do y'all want to complete this little rule? Equals what? Like the square root
I'm
of
going to put in an extra step here, okay? If you have something times itself, if you have a quantity times itself, isn't that the same thing as using the exponent square? That's the same thing as saying the square root of A squared. The square root of anything times the square root of anything. That means you're squaring that square root of anything. What's that going to reduce to?
Right. Equals.
Equals, you'll have to tell me. What
Say
am I
a
going to
letter.
write here?
A.
That's right.
And that's what he's trying to say. The square root of 11 times the square root of 11. As long as they're the same thing, it's going to equal whatever's underneath there. Let me punch in the answer to number 11.
13, yes, 11.
I mean, number 13. And then sometimes students say, well, wait, I want to do another one like that. How do I do another one without getting it wrong? X out the fantastic. And now it says similar question. Let's do another one. We don't have to write it down, just call out the answer to me. Square root of 13 times the square root of 13 is 13.
That's right.
And just to make sure they get the hang of it, one more. Is another number 13? Similar question. Oh, wow.
Okay, 31. The square root of 31 times itself is just 31.
And you might be thinking, well, wait a minute. How often do you wind up with the same thing times itself?
More often
More
than you
often
think.
than you think. At the end of the semester, you'll
By
be
the
like,
time we're dividing.
yeah, oh, wait. Okay, so next question. Oh, after all of that square root of something times itself,
The square root of 6
you can't
times
use
the
that
square
previous
root of
rule on this
12.
one.
Yeah, we don't have the same thing underneath the radical, so we can't use that previous rule. We'll just keep our radical. What am I going to do to the 6 and 12? 6 times 12, multiplying those, is that 72? And what's the square root of 72? I recall reducing that earlier. What's the biggest perfect square that divides evenly into 72?
36.
36. Y'all remember that?
We did it
popped up
twice.
somewhere.
Wait, flip over. You did it twice.
Oh,
There
yeah.
and
No
here.
wonder it's
Oh, wait,
about-
they can't see.
Oh.
Okay.
Yeah, we did it. We're using 36, and then we did it using, move your finger,
Oh.
using 9 and
Eight. You did it
8.
right down the
Mhm.
final. Oh, yeah, you did.
Yeah,
I don't see
there
it.
it is.
Well, you can't see it. Oh, there it is.
Okay, so we say that's the square root of 36 times the square root of 2, which gives me a final answer of 6 square roots of 2. Number, oh, I can't see the mouse. There it is. So 6 square root of 2 so we have simplified square roots, we've multiplied square roots, now we're going to add and subtract square roots. Switch to my paper.
Okay.
So we multiplied square roots, now we're going to add and subtract square roots. To add and subtract square roots, you need to have what are called like radical terms. Like radical terms have the same type of radical, in our case a square root. You can't have a square root plus a cube root, but you have to have the same type of radical, and you have to have the same radicands. So I'll say you need like radical terms. And to have like radical terms, both of them have to be square roots or cube roots. I'll say the same type of radical. They need to have the same type of radical and the same number under the radicals. You can't add a square root of 6 plus a square root of 7. You have to have the same type of radical and the same radicands.
That radicand is the stuff under there.
And if you have like radical terms, then basically all you're doing is combining like terms. The radical part acts like the variable part when you're combining, say, 3x and 7x. So if you have like radical terms, you then keep the same radical part, keep the same radical part, and add or subtract their coefficients, depending on whether the problem tells you to add or subtract.
And the coefficient is the number attached to the radical in front. It'll make more sense seeing an example.
We could have already done every one. The addition and subtraction is easy. We could have already done this. I probably shouldn't have tried to write out my thought process like that. Let's look at number 15. We have the 7 square roots of 2, 7 square roots of 2, plus, so we're adding 9 square roots of 2. Adding and subtracting radical terms is like adding and subtracting variable expressions, combining like terms. Don't write this down, but if you had 7x plus 9x, 7x plus 9x, you say, well, that's the same variable part, so you write down the x. How do you figure out the number that goes in front of the x? You take the 7 plus the 9 to give me 16.
Like 7 cats plus 9 cats is 16 cats. 7 square roots of 2 plus 9 square roots
You
of 2.
keep the same radical part. So you keep that 7 square roots of 2. In this case, you add the coefficients. 7 plus 9 gives me the 16 for a final answer of 16 square roots of 2.
What do y'all think the common mistake is here? Yeah, you
Yes.
add the radical. That's wrong.
No, that is not. That's like 7 cats plus 9 cats. That gives you 16 cats. As long as you have the like radical part, as long as you have like radical terms, you keep that radical term, you add or subtract the coefficients. Any questions there?
Let me type this in.
For 16 square roots of 2. Oh, my ears are popping. What's the barometric pressure? Does anyone have a barometer with them?
It's called your telephone.
Oh, I know.
Oh, okay.
Oh, is anyone else's ears popping? So we have 9 square roots of y. And Tony, I don't want you to say anything. I'm going to ask him a question, and I don't want you to answer it for him.
Yeah, because
Plus
I told
5
so
square
much.
roots of y. You've been answering the questions I've been asking. There was one time in particular, you just cut to the chase and answered the question before they had time to think about it. Here's my question. On number 16, switch over to my paper.
I'm going to ask him the question, what's the answer?
No. Do we have like radical terms? Okay, what's the radical part that I'm about to write down here? The square root of y. Okay, we have like radical terms. So what are we going to do to the 9 and the 5? 9 plus 5 gives me 14. So 14 square roots of 2.
Why?
I mean square roots of y. I'm still thinking of that square root of 2. So 14 square roots of 2.
Some people can probably do this one without writing anything down. Oh, by the way, when you're typing in answers, don't ever hit a space bar.
And don't use capital letters. No spaces, no capital letters, okay?
Because the spaces can mess up the formatting. And it'll be especially true when we get months from now. And logarithms.
Yeah.
They'll be so easy, except people hit spaces and stuff.
Oh, they'll use capital letters.
Oh, yeah.
That's the worst.
Uh-huh.
Okay. Oh, here's one where we're adding and subtracting, or subtracting and adding, depending on how you want to think of it. Okay, so it's 5 square roots of 7. 5 square roots of 7 minus 2 square roots of, is it a 7? Yes. Plus 5 more square roots of 7.
They can do it while you're writing the problem down.
Yeah, because they don't have arthritis in their hand and stuff, their hand cramping up. I'm going to let you start writing now after this one, okay? Do we have like radical terms? So what's the radical part of my answer? The square root of 7. Okay. Now, we're going to add and subtract from left to right. Looking at the coefficients. Oh, I should have asked, suppose there isn't a coefficient there on that radical. If you see the variable x, and you don't see a coefficient, what do you assume is there? 1. Okay, good. So if there'd been 1 that didn't have a coefficient, you would assume it's a 1. But here we have 5 minus 2, which is plus 5 gives me 8 square roots of 7. Good. I can tell this is going to be a hard-working class this semester.
I wonder if there's any artists in here.
Oh, do we have any artists in here? Last spring, we had an artist. She sat right there at that desk, and she would draw caricatures of us and the highlights of the class. And I was able to start our classes by reviewing what we did the last time. Okay, that's
This only had one of us. This was one of the days.
no, you have
there
your
I
head
am.
down. The computer's messing up, and
Oh, this was the day that everything
thing went wrong. Oh,
And the
look,
videos
she even
and the-
has my cup. There's my cup. Okay, yeah.
Yeah,
Oh.
wow. That was the highlight of the class.
Yeah,
I
that-
love looking at her little videos. I mean, her little
Caricatures.
pictures. Okay. Okay. Oh, wow. Only a few more to go.
Number 18. I'll leave the last two for you to do, okay?
Oh, 10.
2 square roots of 45 minus 2 square roots of 5. And I see a problem. What's the problem? I couldn't hear you? They're not the same. We don't have like radical terms. And by the way, if I say I can't hear you, it doesn't mean, oh, you're saying the wrong answer or something. I just can't hear you, okay? Because he's hard of hearing, and I'll tell you right now, so am I. And before you laugh, back when we were young, we had those earbuds, the big old earphones, you know? That's what causes it, loud music at a young age. Now, think about y'all with y'all's earbuds shooting the sound straight in there. Those big ones have an air cushion. I was reading it years ago in Business Week. They said there's going to be a huge demand for hearing doctors and podiatrists because of the way people wear flip-flops and the earbuds. So don't worry, you have something to look forward to, okay? You have something to look forward to. Huh? What did he say? What did he say? You're gonna, yeah, but you're right. There's a big problem here. We don't have like radical terms. We have a 45 under one of these, and we have just a 5 under the other. Can we get like radical terms? Look at that 5. 5's a prime number. You're not going to simplify the square root of 5. Could you simplify the square root of 45 so that you have a 5 underneath it? 45 is not a perfect square, but let's look and see.
Just going back to something I said earlier, it just keeps building. Just keeps building. You know, we're now using what we did on problems 3 through 11 before we can even do
Number 18, you're right. Okay, what perfect square divides evenly into 45? 9. So here's what you're thinking. You're thinking the square root of 9 times the square root of 5. You still have that black 2 sitting right there in front. What's the square root of 9? 3 times 2. What's our new coefficient there? The square root of 9 is 3 times 2 gives me 6. 2 times 3 gave me the 6. I still have that square root of 5. So we've rewritten the problem as 6 square roots of 5 minus 2 square roots of 5. Now do we have like radical terms? Yes, we have like radical terms. So I'll write down that square root of 5. What am I going to have in front of that square root of 5? 6 minus 2 gives me 4. For 4 square roots of 5 as my final answer. Any questions there? Sometimes you may have to reduce the radicals so that you get the like radical terms that you need in order to be able to add or subtract radicals.
The fact that it didn't give you the option or can't be simplified or can't be combined.
That should have told you it can be simplified.
Yeah, there were some where it would say can't be simplified. Okay.
Suppose this had happened. Suppose this had been the problem. 2 square roots of 7 minus 2 square roots of 5. In this case, I don't think there's anything you can do. You cannot get a like radical term. 5 is a prime number. 7 is a prime number. There's no perfect square other than 1 that divides evenly into those. And so this one would be an example, cannot be simplified.
But they didn't have one of those. But still, it would have to give you that option. Click B.
Mhm.
Where was that 6 from again? The 6 square root
Oh,
of 5?
Okay, look
like-
right here.
Yeah.
Oh, right.
Wait, do you see the square? Do you see where I got the 9 and the 5? That came from the 45.
Yes.
Okay, the square root of 9 is 3 times that black 2 gave me the 6. Did y'all follow her question? Where did I get this black 6? The square root of 9 was 3 times 2 gave me the 6.
Thank you.
Anything else?
Okay,
This is some really good problems here.
and I'll let Tony do the last step, the division. Okay, division. We've added, subtract, we multiplied, then we added and subtracted. So now division.
I do have a question.
Go
I'm
ahead.
listening.
So whenever there are prime numbers, it's just simply it cannot be simplified, correct?
If it's a square, if it's a prime number like 5 or 7, the only thing that would divide evenly into it is a 1, and dividing by 1 doesn't change anything. So yes, okay. And
Mhm.
oh gosh, division of radicals is also called rationalizing. So
And
I'll let Tony take over for the last 2 problems.
we'll see how you do. But I
Look
kept
at this.
interrupting you, so if you want to.
Some terminology. Rationalize, that we're dividing. Rationalizing the denominator. Oh wait, let me switch over to your paper. There.
Division of square roots is also called rationalizing denominators. And what that means is to rewrite the problem so that there
Is no fraction under the radical and no radical in the denominator. You want no fraction under radical symbols. You want no fractions. You don't want no radicals in denominators. You can have a radical in the numerator of your final answer. You just can't have a square root symbol in the denominator.
So to to rewrite the problem so that there's no fraction under the square root symbol, that's like number 19. Look at number 19. There's a fraction under the square root. We don't want that. You don't want a fraction under a square root, and you don't want a square root in the bottom of the fraction.
Okay, so look at number 20. There's a square root in the denominator. You don't want that. You can have a square root in the numerator of your answer. You just can't have a fraction under a square root. You can't have a square root in a denominator.
I'm going to write down number 19. The square root of 17 over 3. Here the fraction is under the square root symbol, so that square root applies to both of them. What I like to do then is to rewrite it. Square root of 17 over the square root of 3. Now I'm going to go back to something we did earlier, something we sort of said we'll use the rest of the semester.
I wrote out a little rule of it involving an A, didn't I?
Mhm.
Involving a square root of A somewhere.
If you take a square root and multiply it by itself, you just get what's under the square root. Like the square root of 11 times the square root of 11. It's just 11. I think we did this 2 other times with this in mind. I think there was a square root of 13 times square root of 13 we said was 13. And the square root of 31 times the square root of 31 was a 31. We didn't write them down, but we did number 13 2 additional times just to make sure we had the hang of it. What I want is I just want a 3 down here in the bottom. I don't want a square root of 3 in the denominator. So what I'm going to do is
There's a trick to this rationalizing.
I'm going to multiply above and below by the square root in the bottom. What happens to the square root in the denominator when I multiply above and below by the square root of 3? What's the square root of 3 times the square root of 3? Just a 3. Using that little rule I said we'd use over and over. Now on top, well, we're no longer going to have a 17. What are we going to have? How do we multiply the square root of 17 times the square root of 3?
For adding and subtracting, you have to have like radical terms. You have to have the same number under the square root, but that's not the case for multiplication. Remember, for multiplication, it doesn't matter if the numbers are different under there. You multiply them and then simplify. So looking back, 17 times 3, that's 51. So you have the square root of 51.
Theoretically, maybe we can simplify square root of 51. Can we? Is there a perfect square that divides evenly into 51? No.
17 and 3 are both prime, so you're not going to get another perfect square factor. But you could go to the list and you could play around. Show them my list, Tony. Show them my list. Where? Gosh, was it that many pages?
Mm-hmm. Oh. See, there's no way you can simplify square root of 51. There's no perfect square that divides anything. So here I'm going to write a sentence. To rationalize, if you go into trigonometry and the teacher says, oh, we need to rationalize the denominator. How do you say, how do you do that? Here's what they want you to say. To rationalize a denominator, multiply above and below by the square root in the denominator. Oh, this looks sort of messy. This is just a square root symbol. This is just a square root, and this stuff here is the y. So what am I writing there? I'm writing exactly what I did here. Once I wrote it as square root of 17 over square root of 3, whatever the square root is in the bottom, you multiply above and below by.
A number divided by itself is just 1. So you're just multiplying by 1. You're not changing a value. You're just changing how it's expressed.
And before I do number 20...
I think I should type in that answer before we get timed out.
Ooh.
So what... hey, we haven't typed any fractions yet. If you need a special symbol, it's going to appear in the toolbar. I see one that looks, the first thing, doesn't that look like a fraction? Blue box over blue box. If you hover over there in tiny print, what does it say? Can anyone tell me what it says there? Fraction. You click that. And now up on top, what do we need? We needed the square root of 51. Now click down in the bottom. What am I going to type there? A 3. Mm-hmm. You cannot, you say, well, 3 divides evenly into 51. You can't cancel something under a square root with something that's not under a square root. You're just stuck with the square root of 51 on top and the 3 on the bottom.
Before we do number 20,
flip back over here. I mentioned trigonometry earlier. Here's something that in trigonometry they rationalize over and over and over. 1 over the square root of 2.
What would he multiply above and below by to get rid of the radical from the bottom? He's going to go times something over something. What's he going to put right here? The square root of 2.
I'll multiply above and below by the square root of 2. And then it falls out so nicely on
1
top.
times the square root of 2. 1 times anything is just anything. What's he going to have on the bottom?
The
Just
square
a
root of
2.
2 times the square root of 2.
It's
This
just
is
a
something every trig student in the world knows. 1 over the square root of 2 rationalizes to square root of 2 over 2. But let's do number 20. It's harder than that example that we just did. But this is the last problem today, so it better be the hardest. Isn't that right? The last problem is always the hardest, right? 35 square root of 2. And today it might be, but that's not always the case. All over 2 square root of 5.
Okay, let's switch.
Read my sentence that doesn't make any sense to you probably. To rationalize a denominator, multiply above and below by the square root in the denominator.
So what are we going to multiply above and below by here? Are we going to multiply above and below by the square root of 2? No. What are we going to use? Okay.
Only the 5. You don't need to go 2 square root of 5.
Just
You could get the right answer. I mean, you could get an answer, but you're going to make the numbers bigger than you need to and wind up having to
reduce more.
Okay? So only multiply by the square root. Don't multiply by the 2 also. So let's see. I guess we'll do the top first. On top, we have a 35. I'll just write that down. But how do we multiply square root of 2 times square root of 5? It's exactly what you would guess. Square root of
square root of 10. I agree.
Now, follow my logic down here on the bottom. The square root of 5 times itself.
What's the square root of 5 times the square root of 5?
Square root of 5.
No, not the square root. Just
5.
Okay,
Good.
5.
And then 2 times 5 is?
What's that going to give us down here? 10.
Good.
Did y'all follow that logic? The square root of 5 times the square root of 5 is just 5. Times 2 gave us a 10. Hey, can we cancel that 10 and that 10 there? What do y'all think?
Yes.
But
Can you cancel something under a radical with something that's not under a radical?
can't cancel the 10s.
You have to look at the stuff that's not under the radical.
This one's a little tricky.
Yeah,
The
I didn't see this
yeah,
happening.
I almost said this was the answer, but it isn't. Look at the two numbers, the 35 and the 10, the ones that aren't under a square root. What could I divide both of those by? 35 over 10, I could reduce by
They're both divisible by what number? 5? Okay,
So
good.
35 divided by 5 is 7. We still have the square root of 10. And in the bottom, instead of a 10, we have a 10 divided by 5 is 2.
And you cannot cancel the 2 with the 10. You cannot cancel the stuff that's not under the radical. The 35 over 10 is the same thing as the fraction 7 over 2. But you cannot cancel that 2. You can't say 10 divided by 2 is 5.
It's tempting. But
It's
you can't.
tempting, but you
Where's
just
the
can't.
7 from?
35 over 10.
Write it over on your scratch paper. Move over a little bit.
Okay. 35 over 10. I'll divide, I'm just reducing. What number divides into both of them? Well, a 5. So if I divided both of those numbers by 5, 35 divided by 5 gives me the 7.
10 divided by 5 gives the 2. Okay? Any questions on there? How do we type this stuff in? I think back to when I was in school, something like this would have been science fiction.
Typing
Equation
in.
editors like this, so easy to use, that weren't in
1989,
DOS.
we worked for a year at Baylor, and I remember there was a technical typist.
She did all of our typing stuff.
And
The whole
she really just could do anything she wanted because she knew how to type that. The chair would let her get away with anything. And I remember saying to the chair, my gosh, blah, blah never does anything that she, except, and he says, we're always going to need someone that can type, a technical typist. And so she's the one here that can do it. And so she gets to do whatever she wants, come in late, whatever. But
now,
I suspect there are
technical typists don't exist anymore.
Everyone's a technical typist. Okay, typing short.
No, I'm telling them. I want them to tell me what do you think I'm going to do first?
To type in the answer.
The fraction bar. Okay. And then I type in, what is it, 7 square root of 10. And then down here on the bottom I have 2.
My goodness, they're all technical typists.
Yeah.
And say okay, and let's see, are we 100? Okay.
Look at that score there.
Now it'll go to Canvas. Sometimes Canvas isn't real fast, but it'll notice it says 23 points up at the top because the 3 videos. You had 20 problems and 3 videos.
I should have mentioned that. The way you have to get the little checks before you can start the problems.
That's counting your problem.
Yeah, that's counting as 3 problems. The way we clicked those videos, we didn't need to watch them. Tony already knew how to do this stuff. But now, any questions? Oh, wait a minute. Oops. No.
Come over here.
Okay, any questions before?
No. I'll print it out or copy.
Yeah, no, I'm just going to do this.
Okay.
Any questions?
What we're about to do now, we'll stop the recording.